Hey, I'm going to do a very quick video to try to show how to calculate formula weights using Excel. This is a much longer than necessary way to calculate the formula weights of the hardness, the minerals that make up the Mohs Hardness scale, talc, gypsum, etc. that I've got here in order of 1 through 10. But it's really more of an exercise in learning how to code Excel. And you can start out by just copying everything that I've got here. Set up the mineral names in one column, the mineral formulas in another. We'll enter the formula weights here in column D, and we're going to calculate them using the atomic weights of all these elements out here that make up the various Mohs Hardness scale minerals. So we'll start with talc as an example. The way we'll calculate the value for talc is that we will look at the total number of atoms needed. So we have 3 magnesiums, 1 or a 3 there. We have 4 silicons, so we'll put a 4 there. We need 10 oxygen, so we'll put 10 under the oxygen case. And then 2 hydroxyl units. What I'm going to do here is center everything just to make it a little more obvious as to how all these various numbers belong. I want to make sure that you're clear that the 2 belongs to that 17. We don't have any water units, so we'll put a 0 there. There are no calciums and no phosphorus and no sulfur, and you can put in zeros all the way across. I'm going to shorten it up a little bit, but you're going to want to complete the formula, which we'll type here. So we'll put equals, the formula weight is equal to 2 times the total number of hydroxyl units, because we had 2 hydroxyls, plus, well, 0 times the water. We don't really have to add this for talc, but other units, other formulas will have water, so we'll add it in, plus 10 times the amount of oxygen, plus 3 times the amount of magnesium, plus 4 times the amount of silicon, plus 0 times calcium, plus 0 everything else, right? 0 times phosphorus, plus 0 times sulfur, and then carry it out to the end of all the elements that you need to describe these minerals. I'm going to shorten it up a bit. But then when we hit return, well, we get 379. That is the formula weight, grams per mole of talc. If we had 1 mole of talc, it would weigh 379.26 grams. Now, the reason we're doing this is what we eventually want to do is set up the same kind of numbers for gypsum. So gypsum has 1 calcium, and it has 1 sulfur. Let's slide over to the sulfur fellow. It has 4 oxygens that are separate from the water units, and it has 2 water units, and 0 of everything else. Now, there is something incomplete in my formula. What I'd like to be able to do is fill down and not have to re-enter it, but I'm going to get the wrong value. If I click on the equation, what I really want to see is 2 times 18, but if I click over here, you'll see it's taking 2 times 0. That's why this value is so low. But if we edit this, we can add some dollar signs to fix that. What happens when we fill down? What we want to do is have the talc row, the entries here for the talc, be replaced with the entries for gypsum. So all the row 4s will become a row 5. But we want the row 3s to remain constant. We're not going to change the atomic weights. So we want the 3s to be fixed. And the way we'll do that is we're going to put a dollar sign in front of the 3. So that'll fix the 3 so it won't change. We won't put dollar signs in front of the 4, just the 3, because we want the 4 to change to a 5. But we want the 3, the row 3, to remain constant. And so all the 3s get a dollar sign. Now I hit return, and if we fill down, we should have the correct formula weight for gypsum. And once you fill in all the entries here, all the way across the sheet, you should just be able to fill down without having to re-enter the equation again. So that's the beauty of Excel. It allows us to make these shortcuts. It's probably not the most efficient way to get the formula weights for these fellows, but it is one way to learn how to program Excel.